Hi, my name is Paul Callis. I'm an astronomer at UC Berkeley and affiliated with the SETI Institute in Mountain View and the Institute of Astrophysics in Irakion, Crete in Greece. And today I'm going to share an experiment I conducted in June of 2022 to see if it's possible to attend a conference using VR. The main breakthrough that made this possible is the drop in prices of both the headsets and the cameras. The MetaQuest 2 VR headset is what I use, and it used to be over $1,000 because it had to be connected to a powerful computer, but now it's roughly $400. And likewise, the video cameras that record in 3D have become very good and have also likewise dropped in price to roughly $400. So two of them together are less expensive than the top-of-the-line iPhones. So if you're a scientist or educator, you can actually try this experiment yourself. You don't need a very large budget like you did in the past, where you might have to outsource the project to a professional company. You can try this on your own and see if it works. So my experiment was to see how well it would work if we used this consumer-grade equipment to attend a conference in VR. The advantages, of course, are reducing the environmental impact of our conference travel and also to make conferences more inclusive and accessible. We could have participation with a wider geographic and socioeconomic reach, and it would be more inclusive for attendees with disabilities or illnesses or provider roles or teaching obligations or even travel restrictions. Many people simply cannot leave their country or may not be able to enter the country where a conference is happening. And also, compared to Zoom, the 3D experience might help in improving the attention that people can devote to a conference through remote participation, and maybe even improve the sense of community and the social bonds that are lost when we're not meeting people in person. So just to be clear, my experiment tests the efficacy of a hybrid meeting where the remote participation, instead of through Zoom, is done through a virtual reality live streaming wearing Oculus Rift headset. This is not an experiment for a VR meeting here on the right, where the meeting space and everything about the meeting is virtual, and the participants are avatars. In the hybrid mode, most of the meeting is experienced as a real event in real spaces with real people. So to show how this is accomplished, I want to review a bit the technology, which actually I didn't know about until very recently. The 3D camera actually has two lenses facing forward and back, and they capture two files. There are two video files being produced in real time, and these two files are then what's called stitched together to create a single file, which is what you see here on the left. And that single file is what's being streamed or what's being recorded and shown later through your virtual reality headset. So the resulting audio-visual experience is very powerful. It creates the illusion when you're wearing the headset that you are in this remote location, just like an in-person attendee would be at this conference. So you can view the scene with your headset, and as you move your head around, you see the room around you. It's also possible to display this on a 2D setting like just YouTube, where you can drag the frame around so you can view the room in 2D, but you have the option of seeing any part of this three-dimensional space. And finally, an editor can actually choose the 2D parts of the 3D video and reframe the video, as they say, so that it just becomes a plain old 2D video, as if you had just taken a regular camera to the conference. So what I noticed are some advantages and disadvantages. First of all, the disadvantages are that the resolution provided by the 3D camera is rather poor compared to 2D cameras. And there are ways to mitigate this to improve what you can see, and I'll get to that later. Also, the person who's attending the conference is wearing a headset and therefore can't take notes, and that might be important. On the other hand, because you're wearing a headset, you really are forced to pay attention. You can't be distracted by your phone or your laptop or anything else. You may be paying more attention to the conference than a person who's actually at the conference. And also, it's well known that these headsets are still rather heavy and can be uncomfortable and can even cause nausea in some people. So it's not clear to me if all of that can be eliminated, especially if a conference lasts several hours a day and keeps going for the entire week. And that remains to be seen. On the other hand, there are plenty of advantages. The online viewer with the 3D headset always has a front row seat, which is an accommodation that is welcome by many people. You can also control the volume and the equalizer of the sound so that it meets your auditory needs. If you're deaf, it's possible, hypothetically, in the stream to have a real-time transcription of what people are saying, just like Zoom has enabled in recent years. And of course, for those who are colorblind or have low vision, there are ways to adjust the video so that it also better meets your needs. I took the camera to the poster room to see what that would look like. So a virtual reality participant can walk through the poster room, and you can imagine this part of the experience could be pre-recorded and augmented so that as you walk through the room, you have links that pop up to each one of these posters. So you can pause and click the link and download the file and read the poster in greater detail using the higher resolution of a file rather than the video stream. Also, I think one of the most important parts is that the virtual reality participant will be able to experience every aspect of the conference that the in-person participant experienced. So in this case, going to a public talk, astronomy on tap at a bar in Leiden, or just walking around Leiden, or going into the space where maybe you have a spot where you can interact with the participants who are there. And last but not least, maybe you can go to the conference photo and you can experience that moment in time where everybody was there getting photographed, and you could be added digitally later into the photograph so that you have this nice memory of being together with all the other participants of the conference. So my experiment was very valuable. I learned a few things of what doesn't work and what I can improve on for the future. The live streaming did not work for me, and that has to do with the details that you can read about here in the fine print. Essentially, I didn't have the right type of internet connection that was needed to stream the conference. And the nice thing is, though, by doing the experiment, I learned what can be improved for my next attempt. And among these ideas, the two of them are shown here on the right. Ironically, one of the ideas is to make a real room more like a virtual room, whereas the efforts usually go into making the virtual space here on the right look more like a real space. One of the problems in the streaming of VR content is the data rate. And the rooms, real rooms, have a lot of information. They're very complicated and they require a lot of data, a high bit rate, and this is difficult to stream. So if you could make rooms simpler so that there's less information, that could help improve the resolution in the information that you want to transmit, especially the information on the screen. And this can also be achieved with preparing the camera properly. The camera can be placed closer to the screen, even on the stage on a tripod, so that it captures the smaller fonts and the smaller graphics better. While the part of the camera that faces the audience can be blocked by a filter, let's say a neutral density filter, or a filter that blurs the scene, so that the part that isn't really needed for the live stream, the audience, then that part can have less information if it's blurred or darkened. Now, the recorded video worked, but again, there was some lesson learned. For example, I should have used a tripod because the shaking, even though I was holding it as still as possible, and the camera actually has a very wide field of view, that is still apparent in the final video, the shaking. And also, some more attention has to be paid to the lighting and how the exposure of the camera is optimized to record details in the bright parts of the scene, such as the screen, where the information content that we want to transmit really resides. All in all, my predictions for the future are that VR will work. It will replace Zoom as the best way to experience a conference as a remote participant. Internet streaming should improve, cameras will improve, the headsets will become more comfortable. Institutions are likely to be able to purchase this equipment for you, and you can sign it out for a week or whatever, just like you would a library book. It's still true that at some countries, they will not be able to purchase the equipment or ever achieve the internet bandwidth that's needed, and they can still use Zoom. But overall, I think VR will become a very powerful tool for astronomers, planetary scientists, astrobiologists to teach their material, to go on tours, to do public events, and to engage with the public. Here's an example on the right where I did a quick VR tour of Skinnaka's observatory. That could be augmented with lectures and information about where we are and what we're seeing, teaching the public about astronomy and telescopes. So if you'd like to see the video, you can go to the VR app, the YouTube VR app in the headset, and look for the search term Leo 360. The conference was called In the Spirit of Leo. That's why you would look for the conference and 360 and set the image quality, the resolution, to 2160, so you can see what everything looks like at the best resolution that's possible. Thank you very much.